Right, the RP72 is back together and it seems to be working nicely. I did have to adjust slightly the FM discriminator and got the sound quality on the FM a bit less sort of distorted. I'm going to kill two birds with one stone this evening. What I've set up here is my audio analyzer again to see what the frequency response of the Hacker is, feeding the audio in through the aerial and plotting it out on the chart on the peak minute software. But it's a bit more involved when you're working with FM, because FM there's a treble boost when they transmit the signal. It's a bit like the RIAA equalization on a record. It's to mask background noise. So what we're doing this evening to get that response, the output of the Spectrum audio analyzer is fed into the Panasonic stereo modulator, where it's fed in to the input of the modulator and is given a 50 microsecond pre-emphasis, which is the UK standard. That should give us the flat response, or the emphasized response on the output. The output comes out and is fed into the input of the Marconi RF signal generator, which is transmitting on 90 megs. So basically what I'm going to do is going to run the audio analyzer, but just before I do that, let me just show you the distortion we're getting on the radio. Now this is just a constant 1 kHz tone, 0.8%. Now that's impressive, I think. I mean, that shows the discriminator is nicely in line, but it shows how clean the Hacker sound is. Very low distortion for a portable radio. I mean, I bet you wouldn't get a portable radio that performs as well as that nowadays. I just noticed that when I was setting the setup up. So what I'm going to do is I'm going to run the frequency response software again, and we're going to do a frequency response check just to see how good it is, and just be interested to see what the tone control effects have and where's the flattest response. It's useful for me more than anything. I mean there might be some people out there who own Hackers would be interested in this, but it's more of a documentation for me really to remember what I've actually done in the workshop. So let's do this then. We'll set it up. We're going to set up the 20 Hz to 20 kHz as normal, and not the 30 kHz that the default is. And I'm going to see if I can find the change the defaults on startup, and I'm going to go 10 points per decade. We've got 1 volt output on the generator, that's fine. The ALC levels activated on the Marconi, that should keep our deviation within 75 kHz. So let's try this. I'm going to start to wind the volume up. Let's set our reference point first. Alright, we'll do it all from here anyways, because the peak minute software will take care of it. So turn the amp. Distortion came from. Actually, it looks like I'm just looking at the input of the I was just looking at the input of the Panasonic. It was actually in a serious overload condition, so I need to drop the levels back again. But that's, apart from this high level of distortion here where we clipped the input of the Panasonic, that looks pretty good. Let's run that again, trace 2. I'm going to drop the levels back to something that won't cause the amplifier to run into such heavy distortion. Let's put it down to about 600 millivolts, which is usually about the sort of level you expect to find. So that's 570. We'll go trace 2 and we'll do it again. Start sweep starting. Got these two LEDs here. This is an indication of input level. It's within the normal range now, so we shouldn't get that distortion. As we do. I don't know what the hell that is. Okay, so apart from that strange distortion, that's the overall frequency response of the radio, and it's very good. It's within 2 dB from well, about 50 Hertz actually. So the frequency response is actually very good. But yeah, interesting. I don't know what the hell that distortion is coming from. It could be an overload on the input of the Marconi, I suppose, but it's something very odd going on there. Anyway, thanks for watching, and more to come.